Let's review exponential growth and decay functions. The word growth, it means gets bigger, taller. Decay gets smaller. Now, how do we know if it is going up or going down? We have to do it from left to right. So if I go from left to right, I see, hey, from left to right, this is going up. So this is increasing, this is a growth. Now, from left to right, I am going down. This is decay. So from the graph, it's always from left to right. Now, the equation for exponential functions is a number times another number with an exponent that varies by variable. The independent variable is the exponent. That's what is exponential. Now, this number that has the exponent is called the common ratio. So if I have a function that is 3 times 5 exponent x, the common ratio is 5. That will be my ratio. But what is 3? When x is 0, remember any number exponent 0, 100. Exponent 0 is 1. 2 exponent 0 is 1. So the initial value is when x is 0. So when x is 0, I am going to have a times b to the 0. This is 1. And a times 1 is a. So the initial value when x is 0 is a. So let's look at these two graphs. When x is 0, remember, this is my x-axis. This is my x-axis. So when x is 0, for this case, this is 4. When x is 0 in the other case, this is, right, this is 1. Sorry. So for this graph, for the top, a is 1. For the bottom, a is 4. Okay, so we did this exponential functions, and now we're going to talk about growth and decay. Let's see the difference in the equations. Now, growth, we saw from left to right, you go up. But the equation of exponential I have, let me change to another color. This common ratio, if my common ratio is greater than 1, is growth. Example, 2 times 3 to the x. 3 exponent 1, 3. 3 exponent 2, 9. 3 exponent 3, 27. So you see it's going up. But if my number, my common ratio is less than 1, example, 0.5, this is my b. When I do b exponent 2, this is 0.25. If I do b to the third power, this is what? 0.125. Gets smaller. As x goes up, my function gets smaller. That's why when b is less than 1, it's decay. What is the difference in the problems that you're going to see with growth and decay? So we saw the graph, we saw the common factor. Let me change the color. So we have when b is greater than 1 is growth, when b is less than 1 is decay. But now this b is going to be 1 plus r. And what is r? Is the rate of growth as a decimal in the formula. So for example, if I am telling you that my money, I put money in the bank and has a rate in the bank, an interest of 5%, it means my money is going to go up at the rate of 5%. How do I plug it in the formula? Do I set 1 plus 5? No. You have to say 1 plus 0.05. You have to write a percent as a decimal. So this will be 1.05. That would be my B for that rate. Okay. What if you buy a car, a brand new car that costs you $25,000? As soon as you get out the door of the dealer, the price goes down. And there is a depreciation that they call it. Okay. Let's say that your car every year lost a value. The rate is 20% of depreciation. It means goes down. That's my rate of decay because it's going down. Now, in the formula, how do I enter? Do I enter 1 minus 20? No. Has to be as a decimal, 1 minus 0.2. That will be 0.8. So that's why you need to be careful. This would be my B. For this case, with a depreciation of 20%. Let's look at some examples. Okay. I have a population in an apartment building is 4,000. Every month, the population goes down by 12%. Okay. What is the initial value at the beginning? Month 0. That's my A. So my initial value says 4,000. That's the initial value. The rate of growth or decay. Okay, they said that it's going down. So this is decay. The rate says 12%, but I need it as a decimal. 12% as a decimal is 0.12. So what is the common factor? Common factor, remember, we have initial value times the common factor. So they are asking for this B, for the common factor. And we saw is decay, so should be 1 minus the rate as a decimal. 1 minus 0.12, this is 0.88. So what would be the equation? The function of the number of population at any time would be the initial value, 4,000, sorry for the squiggly lines, 4,000 times B, 0.88, exponent x. This is the equation that gives me the number of population people living in that building apartment, but certain number of months. Let's look at another example. In this example, it says a certain stock was worth $42 at the beginning of the day. Okay, the market start and the price was $42. This is my initial value. Every hour, the stock goes down, or again down. So this is a rate of decay of 15%. As a decimal is 0.15. What would be the common factor? What is my B? The B is 1 minus, because it's going down, 0.15. So this is 0.85. So what will be the equation for this situation? The initial value times this common factor, exponent x, where x is what? The number of hours after they open the stock market. Okay, a final example. In this case, you start a bank account with $500. Oops, erasing now. There was $500. Let me undo. Okay. So my initial value is 500. Look how they call it growth factor. that's my common factor. If you see the word factor, why are they calling it growth factor? They are calling it growth factor because it says that I am earning interest. So I am gaining money. So that's my B, my growth factor. Okay. To know my growth factor, I need a rate of growth. What is the rate of growth? This is my R. So my R is 8%, as a decimal is 0.08. Now, my growth factor will be, because it's growing, is 1 plus this rate of growth. So this is 1.08. Ooh, my ones always look horrible. Now, what would be the equation? Initial value times my common factor, exponent x. And what is x? Number of months, number of days, number of years. They said every year. So this is number of years. Number of years. Okay, I hope this helps.